Basic probability with set theory. We're going to discuss the definition of an experiment, sample space, event, and finally the probability definition. But in order to do so, we need to have knowledge of what a set is, a subset, and the cardinality of a set. A set is just a list of objects or things. Most of us have constructed a grocery list before. We may include milk, pork chops, orange juice, fish, water, bread, or cereal. This is a grocery list constructed by a mathematician. A mathematician would name the list with a capital letter, like G for grocery. And then the items like milk, cereal, bread, water, fish, orange juice, and pork chops will be written horizontally. This is a grocery list written by a mathematician. This is also an example of a set. The definition of a subset. That's a list of objects or things taken from an original set. So if we wanted to construct a set or a list consisting of all the drinks from our grocery list, this is what we'd do. We'd take the original grocery list and we remove the cereal, remove the pork chops, the fish, the bread, and what we have left is a list of drinks that include the milk, the water, and the orange juice, and this list was constructed from the original grocery list. The list of drinks is a subset of the list of groceries. A mathematician would describe this list this way. Capital letter D equals milk, water, and orange juice. This D is a subset of G. It was a list created from an original list. The definition of the cardinality of a set. That's the number of objects on your set. If you've ever counted the items on your grocery list, you've determined the cardinality of list G. This is functional notation. N of A equals the number of objects on list A. Your grocery list has 1, 2, 3, 4, 5, 6, 7. 7 items are on the grocery list. N of G equals 7. Recall the drink list. D. Milk, water, and orange juice. There are 3 items on list D. N of D equals 3. What does this have to do with probability? Well, actually everything. It's the essence or the foundation of probability. The definition of an experiment is any process in which an observation can be made. This is sort of arbitrary and abstract because observations are made in very many different ways. Observations can be experienced. They can be felt. They can be heard. They can be seen. And they can be tasted. For example, if you toss a coin, you can make an observation from that process. If you have a child, this is also a process in which an observation can be made. If you have two children, this is also an example of an experiment in which an observation can be made. You can roll a die and observe outcomes. You can pick a card from a standard deck. It's another experiment. And you can pick a marble from a bag of marbles. Observations can be made from this experiment as well. Go camping at Yosemite, that can be thought of as an experiment. And going swimming in Maui can also be considered an experiment as well. The definition of the sample space. That is the list of all possible outcomes for an experiment. We denote this list or set with the capital letter S. For example, if you toss a coin, the set of all possible outcomes or the list of all possible outcomes that exist when you toss a coin. You can toss a heads or a tails. That means the sample space will have two outcomes, the heads with the tails. If you have a child, having a child means having one child. For this experiment, the possible outcomes are having a boy or having a girl, so that the sample space will consist of the two outcomes B and G for boy and girl. You can have two children. The sample space here consists of various outcomes. Let's take a closer look. You can have two boys. You can have two girls. You can have a boy followed by a girl. That means the boy was born first and the girl was born second. You can also have a girl followed by a boy. This outcome means the girl was born first and the boy was born second. Consider the sample space. BB, two boys. GG, two girls. BG, boy born first, girl born second. And GB, girl born first, boy born second. This is a sample space when you have two children. The list of all possible outcomes. When you roll a die, there are 6 outcomes. You can roll a 1, you can roll a 2, or you can roll a 3 or a 4 or a 5 or a 6. When you pick a card from a standard deck is a deck of cards in which you have thrown out the jokers. There are no jokers in the deck. This is known as a standard deck. The sample space is any one of these cards. There's 13 clubs, 13 spades, 13 hearts, and 13 diamonds. You can pick any one of these cards. If you have a bag of marbles, now, the sample space is going to be defined in terms of which marbles are in the bag in terms of their color. This particular bag has 1 blue marble, 2 red marbles, 3 green marbles, and 4 orange marbles. Just observe the marbles. If you go swimming in Maui, there's many things that can occur. You can possibly drown. You can be attacked by a shark. You can be stung by a jellyfish. Or you could collide with a surfer. I realize that there are many other possibilities that can occur when you go swimming in any beach, in particular Maui. But this is a list of what things that can occur. You can even have a good time. You can go camping in Yosemite National Park, where you can get lost, attacked by a bear, robbed by a stranger, or sprain an ankle. Please note that there are many other possible outcomes that can occur, and these aren't the only outcomes. It's just an example. The definition of an event E. E is any subset of the sample space. It's another list. Rolling a die. There are 6 outcomes associated with rolling a die. We can describe an event as rolling a 5. We look at the sample space and determine which outcomes are associated with rolling a 5. The 5 is the only outcome associated with rolling a 5. The event of rolling a number that is less than 5. We look at the sample space and determine which outcomes are less than 5. Less than 5 means smaller than 5. The outcomes 1, 2, 3, and 4 are all smaller than 5. We have labeled this event F. Rolling a number that is more than a 5. More than 5 means greater than 5. So we look at the sample space and determine which outcomes are greater than 5. The 6 is the only outcome that is more than 5 or greater than 5. We have labeled this event H. At least 5. Which outcomes are associated with the event of rolling a number that is at least 5? At least 5 means 5 or more. So we look at the sample space. The 5 and 6 are the only outcomes associated with rolling at least a 5. We have named this event J. Rolling an odd number. Look at the sample space and determine which outcomes are associated with rolling an odd number. The 1, the 3, and the 5 are the only outcomes that are odd. We have labeled this event K. Having 2 children. The event of having no boys. No boys means 0 boys. If we look at the sample space, we have to determine which outcomes are associated with having 0 boys. The GG, having 2 girls, is the only outcome associated with having no boys. The event of having 1 boy. We look at the sample space and determine which events are associated with having 1 boy. BG and GB. There are two outcomes associated with having one boy. The first being having a boy first and a girl second. The second outcome being having a girl first and a boy second, both of which mean you have only one boy. The event of having two boys. Having two boys means just that. Look at the sample space. Determine which outcomes are associated with having two boys. The BB is the only outcome associated with having two boys. At least one boy. At least one boy means one boy or more. So we look at the sample space and we determine which outcomes are associated with having at least one boy. These three outcomes are associated with having at least one boy: the BG, the GB, and finally the BB. At least one boy means one or more boys. Picking a card from a standard deck. An event can be drawing an ace. So we look at a deck of cards and determine which cards are aces. The ace of clubs, the ace of hearts, the ace of diamonds, and the ace of spades. These are the aces. There are four of them. An event of drawing a spade. So we look at a deck of cards and we determine which cards are spades. These cards, these 13 cards, are all spades. The event of drawing an ace of spades. So we look at a deck of cards and determine which card or cards are an ace and a spade at the same time. This is known as the ace of spades. There's only one card that's an ace and a spade at the same time. This is known as the ace of spades. An event can be drawing a non-ace. A non-ace means a card that is not an ace. So we look at a standard deck and determine which cards are not aces. All of these cards are non-aces. A non-ace means not an ace. Do you see any aces in this list? Not at all. The event of a card greater than a 4. A card greater than a 4 is larger than 4. So we look at a standard deck and determine which cards are larger than 4. These cards are all larger than 4. Notice something interesting here. The ace, which sometimes comes after a king, is not on this list. We have assumed that the ace is considered to be a low card, meaning the ace is smaller than a 2. So it won't be on this list. This is a list of cards that are greater than 4. Picking a marble from a bag of marbles. Recall our bag has 1 blue marble, 2 red marbles, 3 green marbles, and 4 orange marbles. We can define an event as picking a red marble. There are 2 outcomes associated with picking a red marble. We can define an event as picking a blue marble. There's 1 outcome associated with picking a blue marble. We can define an event as picking a non-red marble. Now notice, blue is not red, green is not red, and orange is not red. So all those marbles associated with those colors are all not red. The 1 blue, An orange, green, another green, another green. That's the three green marbles. 2 orange, 3, and 4 orange marbles. All of these marbles are not red. The definition of the probability of an event. The probability of an event is defined to be the cardinality of list E divided by the cardinality of list S. That's the number of outcomes associated with the event E divided by the number of outcomes in your sample space. For example, when you toss a coin, what's the probability that the coin lands on a heads? The sample space consists of the two outcomes H and T, heads and tails. The event is landing on a heads. The only outcome associated with the heads is the H. So there's one outcome associated with heads out of the two possible outcomes. There is one outcome out of two possible outcomes when you toss a coin that consists of tossing a heads. Numerically, the answer is 0.5. That is, the fraction of 1/2 is 0.5. So the probability of tossing a coin and it landing on a heads is 0.5. Tossing a coin. What's the probability that the coin lands on the tails? The sample space is associated with the H and the T. These are the only two outcomes that are possible when you toss a coin. The event of the tails corresponds to the one outcome, which is the T. Since there's one outcome associated with the tails out of the two possible outcomes, we can determine the probability. There is one outcome out of two possible outcomes consisting of tossing a tails. We have seen numerically that the answer is 0.5. That is, the probability of tossing a coin and it landing on a tails is equal to the probability of tossing a coin and it landing on a heads. They are both 0.5. When you have a child, what's the probability that you have a boy? There is two outcomes associated with having a child. The outcome of having a boy or the outcome of having a girl. The event of having a boy consists of the one outcome, the little b. Since there's only one outcome associated with having a boy and there's two outcomes that are possible, we can now determine the probability. There's one outcome corresponding to having a boy out of two possible outcomes. Numerically, this is 0.5. Probability of having a boy is 0.5 when you have a single child. Having a child, what's the probability that you have a girl? There's two possible outcomes, having a boy or having a girl. The event of having a girl is associated with the one outcome little g. There's one outcome associated with having a girl out of the two possible outcomes. we can now determine the probability. There is one outcome out of two possible outcomes that consist of having a girl. Numerically, we have seen that this also is 0.5. So when you have a child, the probability that it's a boy is equal to the probability that it's a girl, both being 1/2. Those events are equally likely because the probability is equal, the same value. Having two children. What's the probability that you have? First question is no boys. Second question, one boy. Third question is two boys. The fourth question is at least one boy. Remember, there are 4 possible outcomes associated with having two children. For the first question, the event of having no boys, remember that there's one outcome associated with having no boys, the GG. The event of having one boy, there were 2 outcomes associated with having one boy, the BG and the GB. Having 2 boys, remember there was one outcome associated with having 2 boys, the BB. And at least one boy, there were 3 outcomes associated with having at least one boy, the BG, the GB, and the BB, because at least one boy means one boy or more. In this case, it's one boy or 2 boys. All we have to do is count, and we can determine the probabilities. For 2 children, there's only one outcome out of the 4 possible outcomes that consist of having no boys. That is there is one outcome out of the 4 possible outcomes that correspond to having no boys. For no boys, there is one outcome out of the 4 possible outcomes. Numerically, the probability is 0.25. For having one boy, the 2 outcomes out of the 4 possible outcomes, which is 1/2. Numerically, the answer is 0.5. Having 2 boys, there is one outcome out of the 4 possible outcomes, which we've seen is 0.25 numerically. And having at least one boy, there are 3 possible outcomes out of the 4 outcomes. Probability is 0.75. When you roll a die, what's the probability that the die lands on a, first question is a 5, second, number less than a 5, third, number more than a 5, fourth, a number that's at least 5, and the fifth question is an odd number. Remember, the list of possible outcomes is the 1 through 6. There are 6 outcomes possible when you roll a die. So the event of rolling a 5, remember, there's 1 outcome associated with rolling a 5. So then we could determine the probability. A number less than a 5. Remember, there were 4 outcomes associated with rolling a number that was less than 5. And a number more than 5, there was 1 outcome associated with being more than 5. A number that's at least 5. 2 outcomes associated with being at least 5. And an odd number, there were 3 outcomes associated with being odd. We can determine the probability. When you roll a die, there is the 1 outcome out of the 6 possible outcomes that consist of rolling a 5. If we approximate this answer to the nearest thousandths, the tenths, hundredths, thousandths, the second 6 is in the thousandths position. If we look at the digit to the right, which is another 6, that means we add 1 to the second 6. So the answer is going to be approximately 0.167. Less than a 5. There are 4 outcomes out of the 6 possible outcomes, which reduces to 2/3 as a fraction. If we approximate this number to the nearest thousandths, tenths, hundredths, thousandths, it's the third 6. We look to the right, there is another 6. We add 1 to the third 6 for an answer of 0.667. There is only 1 outcome that's more than 5 out of the 6 possible outcomes. Approximated to the nearest thousandths, again, this is 0.167. There are 2 outcomes out of the 6 possible outcomes that correspond to the event of being at least a 5. This reduces to 1/3. If we approximate this answer to the nearest thousandths, the third 3 is in the thousandths position. We look to the right and it's a 3. That means we do not add 1 to the third 3. So the answer is approximately 0.333. There are 3 outcomes out of the 6 possible outcomes that correspond to the event of rolling an odd number. This reduces to 1/2, which we have seen is 0.5 numerically. Picking a card from a standard deck, assuming again ace is low. What's the probability that you pick a card that is a, first question, ace, second question, spade, third question, ace of spades, fourth question, a non-ace, and the fifth question, a card greater than a 4? Remember the first event? Picking an ace. There were 4 aces out of the 52 cards. Picking a spade. There were 13 spades out of the 52 cards. The ace of spades. There was the 1 ace of spades out of the 52 cards. We can determine these probabilities. The event of picking a card that's a non-ace. There was 48 non-aces from a deck of 52 cards. The event of picking a card greater than a 4. There's 36 cards greater than 4 out of the 52 cards total. We can determine these probabilities. There are the 4 aces out of 52 cards, which reduces to 1/13 as a fraction. If we approximate this answer to the nearest thousandths, the 6 is in the thousandths position. The digit to the right is the 9, which means we add 1 to the 6 for an answer of 0.077. The 13 spades out of 52 cards reduces to 1/4 as a fraction. We have seen that this is 0.25 numerically. There is 1 ace of spades out of the 52 cards. If we approximate this answer to the nearest thousandths, the 9 is in the thousandths position. The 2 indicates that we leave 9 alone. We do not add 1 to 9. The answer is 0.019 numerically. The 48 non-aces out of the 52 cards. This reduces to 12 over 13 as a fraction. The 3 is in the thousandths position. If we look at the digit to the right, it's a 0, which means we do not add 1 to the 3. The answer is 0.923. The 36 cards that are greater than 4 out of the 52 cards. This reduces to 9 over 13 as a fraction. Numerically, this 2 is in the thousandths position. If we look to the right of the 2, there's a 3, which means we do not add 1 to the 2. So the answer is 0.692. Picking a marble from a bag of marbles. What's the probability of picking a red marble, a blue marble, and a non-red marble? Recall the bag. There were 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 10 marbles. 2 marbles are red out of the 10 marbles. 1 marble is blue out of the 10 marbles. And 8 marbles are not red out of the 10 marbles. We can determine these probabilities. The 2 red marbles out of the 10 possible marbles reduces to 1/5 as a fraction. Point 0.2 is the numerical value. The 1 blue marble out of the 10 possible marbles. The answer is 0.1 numerically. There are 8 non-red marbles out of 10. This reduces to 4/5 as a fraction. The answer is 0.8 numerically. Recall the Titanic mortality table. This table summarizes the number of passengers who survived and died, and the sexes of the passengers with their age groups. 706 passengers survived, 1,517 passengers died, for a total of 2,223 passengers. There were 1,692 men, 422 women, 64 boys, and 45 girls aboard the Titanic. If you select a passenger at random, what's the probability that the passenger was a, question 1, a man? Question 2, the passenger survived. Question 3, a man who survived? And question 4, a male who survived. The event of being a man, well, there were 1,692 men aboard the Titanic, and there were 2,223 passengers. We can compute the probability. Survivors. There were 706 survivors aboard the Titanic out of the 2,223 passengers. We can also compute this probability. The 1,692 men out of the 2,223 passengers If we approximate this answer to the nearest thousandths, the first one is in the thousandths position. We look to the right. We see a value of another 1, which means we do not add 1 to the first one that we see. The answer is 0.761. The 706 survivors out of the 2,223 passengers. If we approximate this answer to the nearest thousandth, we look at the 7, it's in the thousandths position. To the right of the 7 is a 5, which means we add 1 to the 7 for an answer of 0.318. Men who survived. There were 332 men who survived the Titanic out of the 2,223 passengers. Males who survived. Recall, a male is a man and a boy. There were 361 surviving males out of the 2,223 passengers. We can answer these probabilities. Survived out of the 2,223 passengers. If we approximate this number to the nearest thousandth, the 9 is in the thousandths position. We look to the right of the 9 and there's a 3, which means we do not add 1 to the 9. We leave it alone. The answer is 0.149. The 361 males who survived out of the 2,223 passengers. If we approximate this number to the nearest thousandths, the 2 is in the thousandths position. We look at the digit to the right and it's a 3. The answer is 0.162.